dear friends, and welcome to our popular IoT webinar. I'm Alan, HARDWARIO CEO.
And I'm Pavel, HARDWARIO CTO. Hello, everybody.
Today we are going to talk about how IoT, Internet of Things technologies, can help to optimize energy consumptions. Not only energy consumptions, because this topic is much, much bigger, right?
Yes, exactly. And because we are an IoT company, we will be talking about monitoring of energy consumption by online telemetry through our devices and solutions and projects we have done already in this area.
So we can see basically three main trends. One is, of course, the increase of energy prices. And if you want to save money, you have to what?
You have to measure it.
Measure consumption, for example. The second thing is that we can see that there are new trends speaking about alternative resources, sources, right? Like
photovoltaic, solar panels,
heat pumps,
wind power plants.
All these kind of things. And of course, we have to mention ecology aspect, and because we want to be
everybody wants to be green today.
Yeah, we want to protect our planet. So all these three things we will be talking today about. Right, so let's talk about some theory, right?
Okay.
Pavel, when we are talking about energies, what kind of energy we can monitor, we can measure?
So we can measure the consumption of water.
Yep.
Or for heating, we can measure consumption of gas.
Yes.
And most obvious type of power consumption we usually deal with is electricity.
And why it's so? Because probably this is the easiest energy we can waste, right? Electricity. And so maybe we can go a little bit deeper with electricity. We have much more experience in this area. We have many projects, running projects. So speaking about electricity and how to monitor electricity, I think that the standard thinking about this is to measure at the high level, like measure electricity meters or monitor electricity meter. But there is one problem with this. Do you know which one?
So if you are, for example, measuring energy consumption in the cabinet, in the source where there is this income of energy, you don't know, you know the power consumption of the facility, but you don't know where the power really goes. Exactly.
This is, that we have to focus on this specific devices or processes and measure at these spots, in these discrete levels. This is very important. And this is the area when IoT can help a lot. And so we can talk about this. But let's start with these electricity meters. How we can measure electricity consumption at this level when we are speaking about meters.
So there are a few methods. Probably each cabinet is today equipped already with some existing energy meter, which is certified and installed by the distribution company. And for that case, you can use its output, but you have to basically comply with their requirements and regulations. But they have all sorts of outputs. One of them is optical output, so there is infrared, and you can just monitor pulses from this infrared LED, or you can connect to this output called S0, which provides the number of pulses which directly correlate with the some number of kilowatt hour consumed. And this is all nice. It has one caveat, which is actually that you don't differentiate whether you have consumed energy in a low tariff or high tariff. So it will not give you complete insights about the prices of the energy you have consumed.
But definitely it's better than nothing.
So exactly. At least you know how much energy you have consumed whatsoever.
I remember we have one running project with S0 interface. It's with Vodafone, and we are sending data to their platform called Invent.
Yes.
Right. So it was very simple, to read this S0 interface using our Chester devices, sending data over narrowband IoT network to our cloud, and then to Invent application.
Yes, and you simply integrate the total number of pulses.
So we are still there. You mentioned optical ports, S0, but there's another method how we can, in this case, by the wire, how we can gather data.
So I was talking about this caveat that you cannot distinguish the type of energy you have consumed, but there is a solution. There are these smart energy meters which provide some sort of digital output, and typically these industrial energy meters, they very often come with RS485 Modbus interface. So you can connect it to PLC machines, or in our case, to Chester, which can act as a gateway for these energy meters. And we have implemented such energy meters in the past. Actually, for our partner, for our project we have done in Australia for company Sudan, and this company is monitoring power consumption of the street lighting in the city of Canning. So that was an interesting one, and this energy meter provides the way how to distinguish tariffs, and it will tell you all this current measurements and total consumption over some time. So lots of parameters you can read out from it.
So basically, the protocol is very well known, the Modbus, but still, we have to do some programming. We have to.
Yeah, so you need to know the types of registers, what the customer cares about really. So it was like in our case 10 or 12 registers we were fetching from the device, and of course you need to do some configuration of the energy meters. There is also, but it's a different talk, how to really connect the energy meters, because there are these direct and indirect measurement methods. We will also talk about some indirect methods a little bit later. But the nice thing is that you don't really worry about all these measurement details. The job has been done for you. You only read out the value that has been already processed and from a device which is certified.
So again, this project, we are using Chester's devices, LoRaWAN as a connectivity option, and it wasn't that much difficult. The only thing was, to know these registries, and
yes.
This is.
So usually when we know the specification of registers, it's usually a few hours of work just to update the tables and define what is the required transmission interval. The big advantage with this energy metering is that usually you don't need really real-time updates. Usually once or twice a day will do the job. And the neat thing is that you can even use Chester in low power mode. You can keep the RS485 in suspended mode and only wake it up when you really need to read it. So even over RS485 you can do low power acquisition, which simplifies the device installation.
Definitely, these battery operated devices, the installation is it's done within minutes.
Yes.
Seconds?
Wow.
Let's keep minutes. Great. So it was Modbus, but you already mentioned because there is one issue. An issue, it's because some electricity providers, they don't allow you to connect any device to electricity meters because they are the owners.
Yes, exactly. Usually you cannot interfere with them.
So let's talk about Czech Republic. And this is very complicated, so we have to use some other...
You still have the option to install your own energy meter, like just behind that point where it enters your cabinet. So first of all, it increases some costs, but also you might not be that lucky that you have room for that, because it occupies some space, and usually these energy cabinets are fairly utilized. So we will talk about these point of load measurements now. which provide you actual insights about the power consumption of these appliances.
But let's, because we still, yes, Czech Republic, it's a little bit complicated here, but we are a global company, so luckily we can have we have partners, abroad, and they can use it, with the standard electricity meters. So again, Modbus has zero interface, but in some cases we have to use non-invasive methods. So we are still, trying to get data from electricity meters. We are using, and we have a nice project running even in Czech Republic with a company called Smart Systems. We just started, but we are using these special non-invasive sensors like LEDs, magnetic
optical port.
Not optical port, but it's more like this LED, this flashing LED. So this is one method. The second one is using this numeral, this.
So
there's a magnetic.
It's generating magnetic pulses.
Yeah. So we can count these pulses, and this is very simple. Again, the installation is done within several minutes, and you can have this information, and it's very accurate because it's the same like this flashing LEDs or these turns, just pulses.
Absolutely.
And we count it.
With one limitation, you don't again distinguish.
But let's go back a little bit because we were already describing this high level measurement, which is great. We know the whole consumption. But the problem is, it's difficult to be sure where the electricity is being consumed, right? Because you have to point, and you have to, if you want to optimize, you have to be sure where it is being consumed. And now we have a solution, and we know how to use IoT and to measure each device, each process.
And usually you will typically find out that there are some appliances, there will be usually few of them, which make up 80% of the energy. And this is where it makes sense to focus on these appliances rather than optimizing some insignificant LED, which you might have feeling that is always on, but it just doesn't add up really to your overall power consumption.
So I do remember from the economics like ABC analysis. So you will divide these devices, these appliances, into three groups basically. The A is the most important, where the 80%, for example, consumption is consumed. So this is something we can use, and we can call it IoT energy audits. You can do it, in just few days. You can have an energy audit of your whole production, for example, production plant.
Exactly.
So now let's talk about technology, which is behind this. How we can do it, how we can easily monitor consumption of each device, for example, in this production plant.
So for these point of load measurements, let's call it that way, because it is saying what it's really doing. We can monitor power consumption by measuring current flowing into the appliance, and you can do it in really, let's say, non-invasive manner if you have access to the cabinet, to the local cabinet, point of load cabinet, where there is this installation of wires. And we have done one case. We will talk about it later, but in reality, it means that you can attach these so-called current transformers to the lines, to phase line, and then such current transformer provides proportional output to the current flowing into the appliance.
And that's what we are using right now. And again, the combination of wireless, mostly battery-operated sensors, narrowband IoT or LTE-M or LoRa, but LP1 connectivity technologies, and this non-invasive current probes. This combination, this is the beauty of our solution.
Yes, exactly. There are actually two types of these current probes. One is really this traditional current transformer. You will find a plethora of them in the market. But we are using actually a Hall sensor, which also works for DC current. So it's also sometimes referred incorrectly as a DC current transformer. Again, we have picked that one for one particular project because we were measuring the machine operation. It was a vehicle cleaning machine. So there was a DC voltage and the battery, and we had to monitor to which power rails the current is flowing. Mm-hmm. So in that case, you are out of luck with current transformer because it doesn't work for DC currents. So this Hall sensor can actually operate in this DC domain, but also in AC domain. But of course, if you want to measure the AC current, you have to do a bit of math. So it's not enough just to make a single acquisition of the output of such sensor. You have to do some sampling. And because the AC line has a frequency 50 or in some cases 60 Hertz, you have to do some sampling, which is at least twice the frequency of this base line frequency. And you have to measure it for some time to get enough samples and calculate so-called RMS value, which stands for root mean square. Or in another word, it's basically a transformation of energy if you were about to supply it in DC current. Mm-hmm. So in other wording, you basically get the same area under the energy if you plot it in the graph. So that's the whole point, and there is a simple formula. You have to simply add up all the samples, all root squares, and then you will get this RMS value, and you can present this as the current flowing into the appliance. And of course, you are not measuring voltage, which is essential. Of course, mm-hmm. voltage can be floating, so you don't know what is the exact power consumption. But based on the current, you have good enough insights to decide whether this is the main load of the energy.
And now it's time to describe two running projects when we are using current sensors. Mm-hmm. Let's start with a project with our partner. It's Czech Technical University in Prague. And we are monitoring energy consumption in one small brewery. Mm-hmm. So how it started, what we are using, we will, we can show our.
Yes, so it was our very first deployment. So mm-hmm. We learned some aspects on this project. Because we didn't have very clear idea like what the installation will really look like, mm-hmm. What are the appliances, everything. So we have prepared these we call it middle boxes, mm-hmm. which enable you to plug in the socket, mm-hmm. and inside the box we have the AC phase line without the shielding, and there we have inside the sensor. And it continues again with the socket to the appliance. However, we haven't used it in the end much because we were able to attach to phase lines mm-hmm. directly in these cabinets, which turned out to be much easier for installation. Mm-hmm. Yep. And still the installation was pretty fast. Mm-hmm. The only factor we had to consider was the maximum current mm-hmm. for the given appliance. Because for that you want to optimize the current sensor. They make it in various ranges. We use those from I think 10 amps up mm-hmm. to 1500 amps. Yes. And we have actually used the whole range already for some industrial environments. And you just reconfigure this range directly in our Chester device we have this catalog application called Chester Current, which enables to hook these sensors to it. And once you configure it properly, it reports the current, the RMS current, as I was explaining earlier. So if you then sample these RMS measurements frequently enough, you will get a nice overview, not only about the power consumption, but also about the utilization of the machine you are measuring. So this again addresses our previous topics, this overall equipment efficiency, and seeing how do you utilize machines in production lines and so on. But also as a side effect, of course, you get this idea about power consumption.
We'll see how this project will develop, because Technical University, they are using their students, and they will work with data. So right now we are just collecting data, measuring, these devices. This brewery has selected the devices, and we are just sending data right now, and we will see how it will go, how it will develop. But definitely we will see very soon some areas where we can save the energy. And this is perfect. And with this university, we have another running project which goes to restaurants. So we can see that it's not just tied to huge companies, huge plants. We can use it even in some small businesses. So
exactly.
This is great.
Then we have this project where we have deployed these current sensors in the production floor in the factory.
And it was the opposite. So we've been asked, to use current sensor or measuring the consumption to show the production or the tact.
That was the primary goal.
But yes, so it's very nice. It's a company called Tocos. And we are just started this project, and again we will see, how it will develop. But the installation, I remember, it was very fast. It took just a few hours, and we were able to monitor the very first 10 machines. We are using narrowband IoT. Another magic happened because we are sending data from the electrical cabinets, metal ones, with just internal antenna, and we still have signal of the narrowband IoT network. And I was so surprised that it was even without using the external antennas.
And we have fairly fast signal acquisition, as far as I remember. Like every 10 seconds, we acquire the signal, we measure the current, and we send it every minute. It's a lot of data what we generate just from these 10 machines. And it provides, when you set the proper thresholds for lower and higher limit, you can get this OEE thresholds when the machine is running and when it's not. And as we said, we also know how much it takes of the energy.
Yeah, and the last thing, is that data, what we did as integration, we are using the Microsoft Azure tools and Power BI. So very nice dashboards and reports, are generated by Power BI. Great. Pavel, what you mentioned, in the beginning of this webinar was that it's not just about to measure electricity, but there is some new legislation coming that businesses, but much of households can report the heat consumption not once a year, but every month. So now it's a huge opportunity, not just for us, but for many other businesses. How to implement IoT devices in this area, and we are very happy that our partner Vanema work with us, and we are working on this project when we are using some other technology, which is
called wireless M-Bus.
Wireless M-Bus.
And over the past years, many of these wireless M-Bus meters, all sorts of types, have been already deployed and installed. still there is, I would say, lack of gateways for it in the market. And we figured out that Chester with NB-IoT is actually a perfect solution for that. Because if you want to deploy it widely, you have to consider all different locations, and you don't want to struggle with signal availability, and this is where NB-IoT has some leading edge, so it's a really suitable technology. And we are now developing this extension module for Chester with wireless M-Bus module, and that one is simply switched on a few times a day, which is definitely suitable. And you can switch it on just for a few minutes, because these wireless M-Bus sensors, they use fairly fast modulation, and they can transmit, or they transmit the signal every few minutes. It can be 2-3 minutes, and they do it fairly quickly, and then they go to sleep. So you can switch on your radio module for 5 minutes a day, listen to the whitelisted devices that you care about, and you gather data and you pass it to cloud for parsing, because there are lots of types of meters. So in the end, we decided that we will not parse the payload data of these energy meters and on the edge. We will better do it in the cloud, because this is where we have way more flexibility. But still, you need to somehow filter which kind of devices you accept on the edge, because there can be hundreds of them. This is what we design the system.
So let's point few features of this solution. The very first, it's a Chester narrowband IoT / LTM, collecting data through this module and using wireless M-Bus technology.
Typically on 868 megahertz.
868 megahertz, and it's still battery operated, but we have to use
much bigger energy source. Yeah. So this is why we have developed this special carrier board with battery holders, which can ingest like over 100 amp hours of battery, and it can switch on the radio fairly often, and still guarantee multiple years of operation. Because again, if you deploy such devices in the field and you want to save on the cost that every month you don't go there physically and gather the data from the air, and you want some machine to do it for you, you probably want to keep
So we are
it
talking
running for
about
years.
how many years?
We are targeting more than 5 years.
5 years.
Yes.
And the last feature is how many these wireless M-Bus calorimeters we can connect to one Chester.
So we design the software to be able to accept like 250 meters.
So you will install it to some data room in the building, and then you can collect data from up to 300 or 250 calorimeters.
Probably you could do more, but then again, it's probably a matter of limitation of how much data you can transmit per your SIM card. So you can do more locally, but then it makes sense to maybe get more devices operating there as a gateway for you.
Great. So and now let's talk a little bit about the project, which is, it hasn't started yet, but we are talking about this, and it's about how to monitor these alternative energy sources. So what's going on now? It's a trend. Heat pumps, photovoltaic plants, these wind power plants. All these technologies are, they want to replace the standard electricity sources.
Or improve their efficiency.
Or improve, yeah. And so there are many companies entering this market. And again, luckily we have our new partner called Walter. And so...
Yeah, we teamed up very, very recently. And it looks like a promising opportunity, because they have the vision that they want to simplify the whole process to get a heat pump in your facility, in your household. And I feel this is really necessary, because it's a fairly complicated system, and many people are not very aware of how it really works. So the problem is that usually these heating pumps, they are controlled by traditional PLC controllers built inside them. And often they offer some sort of connectivity through Ethernet and other systems. In some cases, this can work. On the other hand, you are always somehow dependent on the local infrastructure. You don't know how reliable is the ISP, and Voltaire wants to provide a premium service for the customers. So we are talking about the way how to connect our Chester communicator as an independent system to the controller that is already in there, but we can provide reliable communication that will even work in case of power failure. So the Voltaire as a service company will have complete overview what's going on and how can enhance their service. And there are several features we can provide. Monitoring of the temperatures, of the systems, of the power consumption we have just talked about, and also provide some back channel for controlling the system so they can do some action, or maybe in the future also to reconfigure some parameter in the controller, because these PLC machines, again, they are offering Modbus interface. So this is a really promising opportunity, and we have all the bells and whistles on hardware level, and now we will be exploring how to move this cooperation further.
Okay, so again, it's based on Chester IoT Gateway. Maybe you can mention these extra modules we are using, like a X7 or a Chester K in this case. In these cases, so.
That's true. We have forgotten to mention it in the context of these current probe sensors, but of course they need to be interfaced somehow in Chester. And because Chester is extensible, we have created the new extension module called Chester X7, which is in the end a DC-DC power supply, which can be switched on and off by software, and differential amplifier. Differential amplifier because these current sensors provide fairly low amplitude, fairly low signal, and to improve the robustness, because it's connected over cable, they provide this differential output. So in case you have some external source of emissions, interference, it will be just it will add up on both cables, on both wires, and you are just taking the difference. So this is why we use differential amplifiers. And we have another module called Chester K, which is the same like X7 but for multiple channels. It can connect up to 4 of these current probes. So Chester doesn't have to monitor only one phase AC line, but 4 of them. Or if you have like 3-phase appliance, you can monitor all phases, and the 4th you can connect to the null cable.
Yeah.
So you have complete overview about all the currents flowing in and out.
Pavel, so I think that we as HARDWARIO, we are ready. We are ready. We know what the energy monitoring and using IoT in energy monitoring can look like. We have several running projects. We have Chester IoT Gateway ready with all these extension modules. We have a nice portfolio of current sensors, these non-invasive sensors. And we have many partners in this area. But still, if you want to be like Vanema or Voltaire, and you want to provide some premium services, don't hesitate to contact us. And let's describe your business to us. And I think that we can help a lot, because this is what is right now all about: to save energy, to be more independent, to build off-grid technologies, and we can help with these battery-operated IoT devices. So now it's time for your questions and to answer your questions. Okay, so let's go to Q&A session. Hello, dear friends, and welcome to Q&A session. And I want to say good evening to Australia, good afternoon to Europe, and good morning to America. Of course, don't hesitate to ask any question using our chat. And Pavel, we have a very first question. Oh, actually, it's not a question, it's a comment from Maciej. For everyone interested, you can read OBIS registers for all tariffs. The meter is aware of using the optical interface. We know this technology, right?
Yes, correct. There is some specification for it, and definitely you can do this digital readout with many data, with tariffs, with all the details, but not all the equipment provides this interface. So we haven't yet implemented in any of our applications, but this is definitely a good and nice approach.
Okay, thank you. Hopefully you are satisfied, Maciej. And now we have a very first question from the recall. How do you guys view the use of C++ language in these constrained IoT devices, like a low power STMs and so on? So which utilize some kind of object-oriented protocol as lightweight M2M. Is it even considerable nowadays?
So I will split it to two questions. First, about C++. I would say that nowadays it's getting quite popular to use C++ on very constrained devices. So again, this is absolutely valid. However, we don't use it, at least not yet. We have adapted technology Zephyr RTOS, and you can read my article about it on LinkedIn. And this technology uses C language because if you do really very low-level bare metal development and writing drivers, it's just easier for us to adapt to it. However, it is possible to enable C++ application level development in Zephyr. So even there, with some limitations which are documented, it is possible to combine C++ and C. I wouldn't say that it adds too much overhead to use C++. Actually, in some cases, there are evidences it can save. Using smartly written templates, it can save some space. But as I said, we keep it simple, and C language is the natural one to the core technology we are using. So we don't feel like any limitation, at least in our case, but it's certainly possible and viable. And second question was about these protocols. So yes, lightweight M2M, it is quite a topic, especially with these LP1 and NB-IoT networks and LTE-M. And actually what we see is that many carriers, operators, they push it for device management. And certainly it has some advantages. The whole idea is to unify device management, streamline the firmware upgrade process, etc. On the other hand, it is also weird on one side, because in lightweight M2M, what you are doing is that you are turning your device into a server. It's using co-op protocol, so it literally works like HTTP server. However, these are sleeping devices, so you have to wake them up first. So there are some hacky things like wake up the device and then they start being a server to which you can make requests. So I don't think that actually is the best model. But on the other hand, we do not deny that in the future, especially if we connect with some very solid M2M technology provider, that we will not implement it. But so far we are going our own way. We have device management through HARDWARIO Cloud. And even if company adopts lightweight M2M, very often they use it only for device management. And the communication channel, how they report the data, is done differently. We have been working on DTLS socket. We have proved use cases. So far we didn't need it much because we have been operating mainly in Vodafone network, which was our own APN, and isolated from public internet. So there you have the security out of the box, and you don't have to deal with these standards. But we are deploying more and more SIM cards, which are, for example, prepaid and so on. So we have to deal with secure transport layers. So we have implemented DTLS. And then it's a matter of how do you, because DTL is just a transport, yeah, so you have to define how you pack the data and how you serialize them. So I can say that for years we have been using very efficient binary buffers. They are efficient because you don't add any extra meta information to your data, to your structure. However, there is a disadvantage that you need to always have a counterpart which takes the binary buffer and produces, for example, JSON from it, which is very hard to maintain if you do such a vast amount of applications as we do. So recently we decided to make a switch. For a little trade-off of data, we implemented so-called CBOR, serialization protocol, and you can look at it like JSON optimized for binary transfers, so it carries like these metadata, like what is the type, whether the next is map or array, and so on. And with a non-specific parser, with general parser, you can retrieve the original structure which is defined by the firmware, which scales much better if you do such a big scale of applications. And this is the way that we are taking for the next development.
Wow, thank you. Yes. And to mention this special prepaid card, maybe you heard about the new prepaid SIM card, narrowband IoT SIM card from Vodafone. It's called Easy IoT Connect. You can find it as easyiotconnect.cz or DE. And roughly, you are paying 20 euros for 10 gigabytes, for 1 gigabyte for 10 years. So it means like several cents, per month. And that's why we need to think about different solution with this DTLS. Thank you, Pavel. And hopefully, the recall, you are satisfied with the answer. We have a question from Guilherme. Hello, Guilherme. Hello, Alan. Generally, the most energy-consuming machines in industrial environment are three-phase. Yes, that's correct. Mm-hmm. Do you usually use a single-phase sensor and assume that the machine consumption is balanced?
In many cases, this is what we have done. Yes. On the other hand, we have the expansion board called Chester K, which is quadruple of Chester X7. And it provides DC-DC step-up, which provides 5 volts for these current sensors. And it provides 4 channels. So you can measure all 3 phases plus null line, and you are safe even if those phases are unbalanced. So sometimes that might be the case that it's not perfectly balanced, and you need to use these multiple channels, and we have solution for that. Mm-hmm.
So, one more question from Maciej. How would you approach measuring gas? Isn't it dangerous to measure it with electric device? Are there any specifications you have to fulfill to measure in these potentially dangerous environments?
Mm-hmm. So generally, yes, you have to deal in these explosive environments with proper devices which are certified, ATEX certified. And we have done such project in the past. We have partner company, Czech company, ZAT, and for them we have made a very specific version of Chester, which is supposed to naturally operate in explosive environment. And we have gone through all the certification process. And yes, it took almost a year. It was a lot of paperwork, and we learned a lot of new things. It was definitely interesting. And in the end, we have taken the approach that the device is sealed. So, because there are lots of ways how you can take it. The other approach, however, and very often you will find it in the industry, is that you will use so-called Zener barriers, which are some safety elements that are on the edge of the explosive zone and on the safe zone. And these Zener barriers, which are some electrical circuits which limit the currents, inrush currents, and so on, to avoid the spark and explosion. So you can install these and use Chester as it is. If it works with the given sensors. Of course, you need ATEX certified sensors, but here again we can maybe recommend some companies. We cooperated with companies like BD Sensors and so on, which have solutions which are ATEX certified and using Zener barriers and digital communication like RS485, you could eventually interface Chester and such sensor. So hopefully this satisfies.
Yeah. Okay, another question from Martin. How do you compare to your competitors such as Energo Monitor? In other words, we are using Energo Monitor now. Why should we switch to your technology? I don't know, Martin. If you are satisfied, stay with them, and that's great. But we can see a lot of opportunities, and basically non-invasive approach, something which is like a mobile. We build it from the ground as a mobile device, so we can switch it. Installation is done within minutes. So maybe because of this, but our approach is different. We are not serving final users normally. We are serving and we are working with our partners. So if our partners are interested into our technology, we are serving them. Maybe this is the answer, but really, probably we are weird and different company. We love our competition, and we are learning from them, and we are doing our best. But we can see many, and especially in this manufacturing era, I can see zillions of machines which are not monitored yet. So this is a potential, and we want to use our devices, our know-how to.
Exactly. We are not building energy monitoring company or something. We are really building a platform that can communicate from deep indoor spaces thanks to NB-IoT and other LP1. It is possible, which runs from batteries. As Alan said, it is non-invasive, and customers and partners use it to build their own solution. So essentially, an Energo Monitor could be the partner who uses Chester to make the energy consumption measurement through NB-IoT and send it to their platform. So this is the story behind it.
So hopefully you are satisfied, Martin. From Guilherme, a last question from Guilherme. What is the maximal quantity to current sensor I can have with a single Chester?
So I mentioned this expansion module Chester K, and that is the maximum we can offer. It's 4 channels. So we can connect these 5-volt powered current sensors in 4 channels maximum.
Thank you. Thanks from Maciej. And from the recall, another question. Do you implement some kind of notifications for aerostates, like power outages or short circuit overcurrents and so on, which could then notify the user to be solved immediately? So I will start to answer this question because, again, we are working with our partners. So normally our partners and their platforms they have this functionality. So they can report, for example, Yotor and their Sarah Hub. In some cases, we are implementing Power BI or the Microsoft Azure. And in these cases, we are using, for example, Teams, to create such a notification. So that's how we are thinking about this. But again, normally our partners and their platforms, they've got this functionality to report these states. If you can add something.
Yeah, it was all mentioned.
Okay. And thanks from Martin and from RG. If we will shoot the Czech webinars in the future, we are trying, to shoot these webinars every month, and because we have many customers and partners abroad, we decided to use just English. Even we are not native speakers, as you can hear, but hopefully, even Czech audience will accept this English webinars, hopefully. And as I was mentioned in the chat, when you got this record on YouTube, you will get the subtitles, Czech subtitles option, so you can use it.
But if there will be too many voices, we may reiterate our decision.
We will see. Another question which was not in the chat, but we got this question through our internal chat from our partners. So let me find where it was here. Yeah. Is it possible, because the question was about how many current sensors we can connect to Chester device, to single Chester device. But what about to connect various energy meters, to one Chester? For example, to combine Modbus on RS485 and current sensors together. How can it be done?
Yes, so this is possible with Chester. It's a platform, and you can customize the assembly of modules. You can tell us that you want to combine, for example, this Modbus energy meter, which can be somewhere at the source, and you want to combine this current sensor, which might be somewhere at the appliance. Again, we have like 2 or 3 approaches. The first approach is that you will find a catalog application of Chester, which is readily available, and you can connect one for energy meter, one for current sensor, and get the data immediately. And usually we are able to ship these units right away. Or there is some demand to really merge it together, make it really customized. And in that case, it takes some time. We have some pipeline for that. And we can even help you to create such firmware and to program the application, to integrate it all together. On the other hand, I would say there is third and probably the most interesting option for those who want to really use it as their own product. We can even help with branding, and these partners usually are able and have vision to write their own application, create their integration, and they have this power to find their own customers and create the business model. And in such case, it makes sense to even provide and include them in our partner program and train and help the developers to get affiliated with our Chester SDK, which is open to partners who want to build such things. And we provide individual training, and we can help you to really create your own customized version of Chester, which will be just yours, and you will have all your ecosystem around it. So yes, these combinations are possible, and sometimes you can create crazy combinations. Sometimes we are even surprised ourselves, and we are still exploring. And in that case, it's the best just to connect with us, talk to us, and we will try to sketch some best solution which will be efficient.
Yes, it's a perfect note because probably the next webinar will be about some general topic, and we are thinking about to repeat the LP1 technology because there were some changes and new trends in this LP1, or maybe we will talk about Zephyr and our approach, to our partners now, because this onion-like, you name it, like onion-like architecture or layers, that on top of Zephyr SDK is a Nordics SDK and our SDK. And for example, our partner, like a Statotest, who is monitoring the bridges, they've got their own layer. So you can build your own layer. You can keep your application. You can keep your IP. That's the way how we are thinking, and we want to, of course, support our partners. So if you are interested to become a partner, don't hesitate. Just send email or call us or whatever channel you will choose. We will answer, and we can talk. How to cooperate in this beautiful area of Internet of Things. And the last check of chat, there is no more question. Thank you so much for joining us, for watching us. Stay with us. Pavel, thank you for your know-how.
Thank you too for all these inputs.
Again, I'm surprised, how smart you are. And see you next time.
Learning all the time.
See you. Take care. Bye-bye.
Bye-bye.